Friday night. You trained a small digit net in TensorFlow and it actually learned. Then a teammate messages you. Their box only has PyTorch. Do you rewrite the whole model? That used to be the tax. One kitchen, one recipe. Change the stove, rewrite dinner. Keras 3 changed the tax. You write one model, then you pick the engine underneath. Tonight we will walk the modern stack TensorFlow's architecture. Keras 3's 3 backends, then GPU and TPU, then a clean environment you can actually run. Stay with me. I will talk like we are at one desk, looking at one file, not like I am reading a brochure. Picture the stack as a ticket and 3 trains. The ticket is your model file. The trains are TensorFlow, PyTorch, and JAX. GPU is the diesel that makes any of those trains fast. TPU is the electric overhead, mostly at Google stations. If you mix those layers in your head, you will install the wrong package and think deep learning is broken. So first, what is the ecosystem really? At the top is the model you write layers, a loss and optimizer, a fit loop. Under that is a front end. Here is that friendly door. You say sequential dense, compile, fit. Under Keras sits a backend. That backend does the real tensor math. TensorFlow, PyTorch, and JAX are 3 different backends. They do not share a kitchen. They share a ticket format if you wrote Keras 3. Under the backend sit devices CPU, GPU, TPU. A device is where the multiply actually happens. Cuda is NVIDIA's software bridge from your Python to the GPU. If the bridge is missing, the GPU is just a warm brick. Accelerate is a compiler. JAX loves it. TensorFlow can use it too. It fuses ops so the chip does less waiting. You do not need all of that memorized tonight. You need the order model keras backend device. Now, TensorFlow's own architecture, because a lot of production still lives here. Think of TensorFlow as a building with 4 floors. Floor 1 is the front end. Python is the usual door. You write tensors, ops, and keras models. Floor 2 is the graph. In eager mode, ops run immediately, which is great for debugging. When you wrap a function with tf, function, TensorFlow can trace it into a graph, then run that graph faster. Floor 3 is the runtime. It places ops on CPU, GPU, or TPU, and it moves tensors between them. Floor 4 is kernels. A kernel is the actual compiled code for one-upon-one device, like a matrix multiply on CUDA. If a kernel is missing for your device, that op falls back or it fails. That is why GPU installs are picky. TensorFlow also has a C API sitting under the Python. Other languages can talk to the same runtime. XA can compile a graph for GPU or TPU. SavedModel is how you ship a trained graph to serving. TensorFlow serving, TensorFlow Lite, and TensorFlow. J's are the production exits. That is a real reason people still choose this train. Keras used to mean TF, Keras glued to TensorFlow. That was Keras 2. Keras 3 is a rewrite. Same sequential feeling, but the floor under it can be TensorFlow, PyTorch, or JAX. The Keras team said it out loud on Keras. You pick the framework that suits you, then switch when the goal changes. You can also write custom layers with Keras. Ops and those layers can travel across all 3 backends. A Keras 3 model can become a PyTorch module, a TensorFlow save model, or a stateless JAX function. That is the whole trick. One model, Py, 3 ecosystems, twice the people who can run your release. OpenVNN is there too for inference only. We will not install it tonight. Know the door exists. Why would you switch backends at all? TensorFlow is the production building. Data pipeline, SaveModel, Lite serving. If you already live there, stay. PyTorch is the research hallway. Hugging face, a lot of papers, a lot of teammates who think in Torch. N. JX is the speed freak on TPU and often the fastest on GPU in Keras' own benchmarks, though not for every model. Keras' launch note said JX usually wins training and inference, but non-XLA TensorFlow can still be faster on some GPU jobs. So you do not marry a backend, you measure. Same Keras code, 3 engines, keep the winner. There is a catch. The backend is chosen before keras is imported. After import, you cannot flip it in that process. That is not a bug. The backend loads kernels at import time. Changing kitchens after the soup is cooked does not work. In Colab, you set the environment variable, then import keras, then if you change your mind, you restart the runtime. On your laptop, you can export keras backend in the shell or edit the keras JSON file in your home folder. The three legal strings are TensorFlow, Torch and JAX, not PyTorch. The PyTorch backend is the word torch. I will show you that on the official getting started page because I want you to see the real docs, not a slide I invented. Now we set up an environment you can trust. Do this in Visual Studio Code in a folder called Treo Lab. Do not install keras into the system Python. You will fight CUDA versions for a month. In the terminal, you make a virtual environment, Python mvenv. When that command says Python, make me a private toolbox named venv sitting in this folder. On Windows, you activate it with venv scripts activate. The prompt should show the name. If it doesn't, you are still in system Python. Then you upgrade pip because old pip lies about wheels. Python m pip install upgrade pip. Now the keras door. Pip install upgrade keras. Keras alone is not enough. You still need a backend. Tonight we start with TensorFlow because it is the classic floor. Pip install TensorFlow. From TensorFlow to 16 onward, that install already brings keras 3. If you are still on 2.15, TensorFlow will shove keras 2 back in, and you must reinstall keras 3 after. Print the port keras, then print keras, dog out the version dot. You want a 3, not a 2. If you see 2, stop. You are in the old glued world, and the backend switch will not behave. For PyTorch as the engine, you install Torch from the official PyTorch. Org wheel that matches your QD, then pip install keras, then set the backend to Torch. For JAX, you install JAX and JAXlib the way the JAX docs say for your GPU or TPU. Then pip install keras, then set the backend to JAX. Do not mix 3 CUDA stacks in one venv unless you enjoy pain. Keras' own docs recommend a clean environment per GPU backend if you are testing all 3. Colab and Kaggle already wired a GPU and a QD. On those sites, you usually should not try to upgrade the NVIDIA driver. You cannot. If you want one laptop VEN that can talk to any backend GPU, copy the versions Colab is using. That is the unofficial peace treaty. Alright, open a notebook. Name it ticket 3 trains IPN. One idea per cell, the way you would teach a friend. First cell is only the switch. You import os because that is how Python talks to environment variables. Then you set os, environ of keras backend to JAX. Do this before keras exists in memory. Then and only then you import keras. Print keras backend. It should say JAX. If it says TensorFlow, you imported keras too early, probably in another cell you forgot. Restart the runtime if you need to flip. Do not fight the already loaded kernels. Stay with me. Next cell, we prove the ticket is the same no matter which train. From keras, datasets, MNIST, load data. That gives you train images, train labels, test images, test labels. MNIST is 60,000 handwritten digits. It is the hello world on purpose, so you watch the stack, not the dataset. You cast the images to float 32 and divide by 255 so pixels sit between 0 and 1. Nets like that scale. Then you expand the last axis, so the shape is 20, 8 by 20, 8 by 1. A convolution wants a channel even if the channel is grey. Print the shape. You should see 60,000, 20, 8, 20, 8, 1. If you don't stop, the model will lie later. Now the model, keras. Sequential is a stack. Data goes in the top, scores come out the bottom in order. First layer is input with shape 28, 28, 1. That is the door. It is not a learned layer. It names the tensor. Then con to D with 32 filters, kernel size 3, activation ReLU. 30, two small detectors look for strokes. Kernel size 3 means a 3 by 3 window. it slides. It is how a net sees a local mark, like the loop of an 8. ReLU keeps the positive detections and zeros the rest. Simple, and it trains. Then max pooling 2D, it downsamples. The net keeps the strongest mark in a small neighborhood and the map gets cheaper. Then flatten. The map becomes a vector because the last door is dense and dense wants a list, not a picture. Then dense with 10 units and softmax, 10 digits. Softmax turns 10 scores into 10 probabilities that add to 1. That whole sequential is the ticket. Notice I have not imported TensorFlow, Torch, or JAX in this cell. Keras is the language. Call model. Summary, you should see the shape shrink and a parameter count that is small enough for a laptop. Compile is the contract. Optimizer Adam, loss sparse categorical cross entropy because the labels are integers, not one hot vectors. Metrics accuracy, so fit will print a number you can feel, not only a loss you have to decode. Then fit, you pass extra train war train, a few epochs, and validation the split of 0.1. Validation split holds out 10% so you can see if the net is memorizing. Watch val accuracy, not only train. If this cell runs on JAX, congratulations. The same cell should run on TensorFlow or Torch after you change the first cell and restart. That is KERAS 3, not a slogan, a restart and a string. Let me say the same story in Visual Studio Code because some of you never open a notebook. Py. At the top, import Oz, set k-backend, then import keras. Same rule, switch first. Then the MNIST load, the scale, the sequential, compile fit. Line by line, it is the notebook without cells. If you write from TensorFlow import keras here, you are taking the TensorFlow door, not the multi-backend door. The multi-backend door is import keras after the environment variable. Remember that when a blog still shows def, keras from 2019. Now devices. A beautiful model on CPU will teach you patience you did not ask for. Open a terminal. Type nvidia-smi. If you have an NVIDIA GPU, you should see the card name, memory, and driver. If nvidia-smi is not found, the driver is missing. Pip cannot fix a missing driver. Install the NVIDIA driver first. CUDA is the toolkit that matches that driver. cuDN is the library of fast neural net kernels. TensorFlow and PyTorch will usually bundle a matching pair. Fit in import TensorFlow as tf.config. List of physical devices of GPU. If that list is empty, TensorFlow is on CPU, your fit will crawl and you will think Adam is broken. On a working GPU, TensorFlow will place ops there without you rewriting the model. That is the point of the runtime floor. For PyTorch, you print torch, CUDA is available. True means the torch wheel found CUDA. False means you installed a CPU wheel by accident. For JAX, you print JAX. Devices, you want a GPU device or later a TPU device, not only CPU device. Keras will follow the backend's devices. You do not usually write a device string in sequential. You make sure the backend can see the chip. If two backends fight over CUDA in one venv, one of them will go dark. That is why Keras publishes separate requirements files per GPU backend. A TPU is a tensor processing unit. Google built it for matrix math at warehouse scale. You will not plug a TPU into a laptop. You meet it on Colab on Kaggle or on Google Cloud. In Colab, you change the runtime to TPU, restart, then set keras Biscayne to JAX, then import keras. JX and TPU are old friends. Keras 3 even has keras. Distribution for model parallel and data parallel, first on JX. TensorFlow can use TPU too with its distribution strategies. PyTorch TPU exists, but JAX is the path Keras is proudest of here. Do not pretend a TPU is a faster GPU. The programming model likes compiled graphs, big batches, and XLA. Tiny eager loops waste it. If you are learning on a laptop, GPU is enough. Use TPU when the model is huge or when Colab hands you one for free this afternoon. KERAS.ops is the cross backend math. It is literally NumPy's API plus neural ops like softmax and conv. If your custom layer only uses keras ops, that layer is a citizen of all three trains. If your custom layer secretly calls tf.n, you just glued yourself to TensorFlow again. The ticket stops working on torch. Same trap with torch. N functional inside a keras layer. That is a PyTorch dialect, not keras. So when you write a new layer, ask could this run if I flip the backend string? If no, you used a dialect. Data is candor. Keras 3 fit can eat TIFF, data a PyTorch data loader, NumPy, or a pandas frame even if the backend is a different family. That means a TensorFlow dataset can train a keras plus torch model. The ticket really is the ticket. When you ship, pick an exit. SavedModel if you need TensorFlow serving or light. A torch module if the next team lives in PyTorch. If you release an open model in only one backend, about half the community cannot sit down. Keras 3 is how you stop doing that. Let me recap the order slowly because this is the whole lesson. Write the model in keras. Set the backend before import. Confirm the backend string. Confirm the device. Then fit. If fit is slow, check nvidia-smi, then the backend's device list. Do not start rewriting layers. If a teammate only has torch, you change the string to torch, restart, and send the same file. That is the Friday night you wanted. When they open ticket, py on a torch box, sequential should still compile. If it does not, you did not write keras. You wrote a dialect and the ticket is only valid on one train. Keep the ticket clean. Let the trains compete. That is the modern stack.